This video is on topic 19, ASA, AAS, and HL. We're going to identify what these 3-letter and 2-letter combinations mean. They involve triangle congruence and talk about additional information needed to prove two triangles are congruent. By definition, two triangles are congruent if all 3 corresponding sides and all 3 corresponding angles are congruent. Last topic, we talked about that there are shortcuts to proving triangles are congruent that don't have us do all 6 pieces. If we can prove certain combinations of sides and angles, we can show that the whole triangles are congruent. We're talking about the remaining 3 today, angle, side, angle congruence. So if 2 angles in an included side of one triangle are congruent to 2 angles in an included side of another triangle, then we can say the 2 triangles themselves are fully congruent. What that looks like is if I have one angle in a triangle, I have another set of angles in another triangle, and specifically we have the side that's between them, the side that links those 2 angles together. If those are congruent, then we can say that the full triangles are congruent. So triangle MLN is congruent to triangle SRT. Don't need the side segment there. Okay. This is very similar to side, angle, side. We just kind of flipped it. Angle, side, angle. Notice again that the side is between the 2 given angles. The next triangle congruence is called angle, side, angle, or AAS, where we have 2 angles and a non-included side, and then 2 angles and a non-included side of another triangle. This also shows that the 2 triangles themselves are fully congruent. If we take a look here, we have angle U matched up with angle X. We also have angle V matched up with angle Y. And the side length that we have here is side VW paired up with YZ. Now notice the difference here. This side is not between the 2 angles, whereas up here it was between the 2 angles. That's okay. This still proves that the 2 triangles are congruent. Triangle UVW is in fact congruent to triangle XYZ. Okay. The last triangle congruency theorem we have is something called hypotenuse leg congruence, or HL. This congruence theorem statement says that if the hypotenuse and one leg of a right triangle are congruent to the hypotenuse and leg of another right triangle, then in fact the 2 triangles are congruent. So this is essentially an angle side-side congruence. However, it's not an angle side side congruence because we're not just using any old angle, we're using a right angle. So hypotenuse leg only works if the angle that we're given is a right angle, and then we have 2 other sides, specifically one side being the hypotenuse, in this case MN, and G and a QP being congruent. And then one of the other 2 legs being congruent. It doesn't actually matter. In this case, we have ML being congruent to RP. So this is our leg for that. If we have 2 right triangles, hypotenuse, and a leg being congruent, then we can state that the full triangles are congruent. Triangle MNL is congruent to triangle P, Q, and R. Let's see what these look like in action. Much like the last topic, we're going to look at several triangles and see, can we prove them congruent, and if so, by what theorem? So let's look at the start of the first 2. I'm looking to see whether triangle DEF is congruent to triangle GFE. I'm going to go ahead and highlight DEF. DEF congruent to triangle GFE. Looking at this, we see that we have 2 triangles. They share a common side, so right off the bat, I know that the side is congruent to itself. EF is congruent to EF. This is by the reflexive property. I'm also given that angle E is congruent to angle F via the diagram, and we're also given that this DEF is congruent to GFE, the other via the diagram. Looking a little more closely, we have 2 angles and a side between them, 2 angles and a side between them. Therefore, these triangles are congruent by ASA, angle, side, angle. Looking at my next example, we're given two sets of congruent angles. Sorry, one set of congruent angles, and also one congruent side, JL and LN. We can add one additional piece of information to the diagram. This angle is congruent to this angle by vertical angles. Now looking more closely at the diagram, we have two angles and a side between them. Two angles and a side between them. Once again, triangle congruence, angle, side, angle. Next two examples. We are given from the diagram that we have angle S is congruent to angle T. And we see angle R is congruent to other part of angle R. If we look more closely at the triangles again, RQS is this triangle up top, and RQT is triangle on the bottom. You see that these triangles share a common side, so that means it is congruent to itself by the reflexive property. Looking more closely then for the triangle congruence theorem, we have two angles and a side that's not between them, two angles and a side not between them. These triangles are congruent by angle, angle, side. Next example, we are given an angle and another angle, and then we're also given a right angle and another right angle. Now, sometimes students automatically think that a right angle means it has to be hypotenuse leg, but let's look a little bit more closely. If I were to go ahead and fill in the shade in the two triangles, we have triangle XWZ is the top, and we have XYZ is the bottom. Since they share a common side, we see that this is congruent to itself. It is, in fact, the hypotenuse being congruent to itself, but the other given piece of information is not another leg congruency, but it's another angle. So, reflexive property. So looking at the diagrams then, I'm given two angles and a side not between them, two angles and a side not between them, then this is, in fact, angle, angle, side, triangle congruency. Let's take a look at the other three examples. Here I am given that this WX is congruent to WY. And once again, I am given a right angle. Now, if that's a right angle, that means that this is a right angle. That's the definition of supplementary. Linear pair, definition of linear pair. And once again, if I were to go ahead and highlight the triangles, ZWX and ZWY, we see that these triangles share a common side, so that must be congruent to itself by the reflexive property. Now, looking at what information I'm given, I am given an angle, a right angle, and I'm also given that this hypotenuse is congruent to this hypotenuse, and I have a leg that's congruent to another leg, so this is an example of hypotenuse leg triangle congruence. Taking a look at the next example. From our diagram, we have a side congruent to a side, and we once again have a right angle and a right angle. If I highlight the triangles again, STM and triangle MNS, they share a common side. You guessed it, reflexive property. Now looking at what we're given, we are given two sides and an angle, but this is a right angle, so this is once again hypotenuse leg triangle congruence. Last example from the diagram, we're given two sides, two sets of congruent sides, and we're given one right angle. Well, we also know that this is a right angle by vertical angles. So looking at my two triangles then, we're given a right angle and two sides, specifically the hypotenuse of both of these right triangles. So this is once again hypotenuse leg triangle congruence. Again, would like to point out the difference between this example and these three. Just because we have a right angle does not immediately imply hypotenuse leg. We need to look and see the given information that's there. Last set of problems. What additional information is required to know the triangles congruent by the stated theorem? So if I'm looking at this example, I want to prove via congruence angle side. I'm given one angle, and technically I'm given that this is congruent to itself if I'm looking at the two triangles separately via the reflexive property. So if I have a side and I have an angle, so I now need another angle that's not that will not trap my side. So that means we're going to have to use angle F, and we're going to have to use angle J to set up angle side for this top triangle, angle side for the bottom triangle. By these congruency statements, we've now set up that triangle FGH is congruent to triangle JHG. Moving over to this example for angle side angle. I'm technically given in the diagram that this is congruent to this by vertical. And we're also given that this angle A is congruent to this angle G. So I'm given two angles, I now need to set up a side that falls between them. Well, this side, AH, falls between H and A, and HG falls between angles between H and G, therefore setting up triangle congruence angle side angle, and allowing us to say that triangle AHC is congruent to triangle GHI. Lastly, hypotenuse leg. I'm given a right angle. That's kind of key for hypotenuse leg. And in this case, I'm given that the hypotenuses are congruent. Hypoteni are congruent. Hypotenuses. Hypoteni. I don't know. Now, that means that I need another leg to be congruent. It doesn't actually matter which one I choose. I'm going to choose US and XV. I could have easily chosen UT and WV. That would have worked as well, since I just need one other leg to be congruent. That finally sets up our triangle UST is congruent to VXW. Simple points of confusion that I find the students make a lot. They get lost in terms of all the different types of triangle congruences, but specifically angle side versus angle side angle, seeing the differences between them. That's the included versus non-included side is always difficult for particular students. Additionally, filling in either, I'm going to say vertical angles or reflexive. Filling in information that's not already given on the diagram can be difficult for students because they simply forget, or maybe just they don't see it. Okay, thanks.